We will see a demo video of columns which carry axial load and a uniaxial moment, and how can we draw a PM interaction diagram for the given section of the column. Okay, so for that we will have to use the following program. Click design, program list. Okay, this is the program where you can draw the PM interaction diagram for I section, H section, T section, L section, cross section and circular section, right? But please remember, this is this draws the PM interaction diagram for an axial load and a uniaxial moment only. Okay, about the major axis or the minor axis, right? So first we will try to draw a PM interaction curve diagram for a rectangular section. Okay, and we just will try to learn that how the input has to be given. Okay, and the procedure for providing the input is same for any section. Okay, so we will start with the rectangular section. Now we will take this section. Okay, this is chart 44 of SP16. Okay, we are taking D as 500, B as 300. Okay, F5 is 415, F6 is 20, D dash, this is D dash is 50 mm, and D dash by D is 0.1, PT by F6 is 0.2. We are going to draw this graph given in the code by our program, right? We are going to draw this graph. Okay, so PT turns out to be 4%, that is equal to 6000 mm square. Okay, now this is the total steel in the column section, and we will give 6 layers of steels: layer 1, layer 2, layer 3, layer 4, layer 5 and layer 6. And this is our major axis, bending axis. Okay, and this steel is equidistant from the equidistance distributed with equal distance, right? Okay, now this layer can have 2 number of bars or 3 number of bars or 4 number of bars. It's up to you. Okay, we just need the total area in that layer, that's all. In the input, doesn't matter how many number of bars are there in each layer. Okay, we just have to give the total area of steel in that layer of bars. Okay, so we will give the input for this section and draw a PM interaction curve. Okay, click this option. Okay, WD. Okay, WD, this is WD, that is 500 mm. Okay, please use enter key to fill the data, to save the data. Okay, so press enter. B is 300 mm. Okay, so press enter. All dimensions are to be in mm. Okay, press enter. Effective cover we are taking as 50, D dash we are taking as 50. Okay, D dash we are taking as 50. Okay, so 50, press enter. Number of steel layers we are taking it as 6, right? 1, 2, 3, 4, 5, 6. First layer is at 50 mm and the area of steel in that layer is 1800 mm square. Second layer is at 130 mm and the area of steel is 600 mm square. Third layer is at 210 mm from the compression phase. This is the compression phase. Okay, and the area of steel in that layer is 600 mm square. The fourth layer is at 290 mm from the compression phase and the area of steel is 600 mm square in that layer. The fifth layer is at 370 mm from the compression phase and the area of steel in that layer is 600 mm square. And this is the last layer which is at 450 mm from the compression phase and the layer of steel is 1800 mm square. So we have to just give this data in our input, right? Okay, so number of layers are 6, steel layers are 6. Press enter. First layer is at 50 mm from the compression phase and the steel in that layer is of area 1800 mm square. Now second layer is at 130 mm from the compression phase and the area of steel is 600 mm square in that layer of steel, right? Okay, now the third layer is at 210 mm from the compression phase. Area of steel is 600 mm square in that steel layer. The fourth layer is at 290 mm from the compression phase. Area of steel is 600 mm square. The fifth layer is at 370 mm from the compression phase and the area of steel is again 600 mm square, right? The last layer, sixth layer, is at 450 mm from the compression phase and the area of steel in that layer is 1800 mm square, right? Now F5 we have taken as 415, FCK we have taken as 20. Say the design load is you can take it as a 1500 kilonewton and the moment is 750 kilonewton meter, right? Okay, press enter, always press enter. Okay, so this is the input data given and you can always check the results. Okay, click analysis T4 to 6. Okay, this command is applicable for type 4 to 6, that is 4, 5 and 6. Okay, so this is type. Okay, so this is something you can see. This is your PM interaction diagram. Okay, and this is on the this is for the compression member and this is for the tensile uh, when the column acts as a tension member, right? And we can see our section falls within the PM interaction curve. That means the section is safe. So this is how you can draw the PM interaction curve for any section. Say you had to draw a PM interaction diagram for I section, then you simply have to give the details. This is WD, okay, this is WB, right, this is FB1, okay, this is FB2, that is this much, this is FD is the thickness. Okay, the assumption is that the thickness of the whole I section remains the same. Okay, you can vary the flange width but the thickness is the same. Okay, so simply give this details. Okay, then you will have to give effective cover and you will have to give the number of steel layers in I section. Okay, say there are 2 layers, this is 1 and 2, then just write 2 over here. Okay, write the distance of this steel layer from the compression phase over here and write the area of steel, right? Then again write the distance of the steel layer from the compression phase and write the area of steel in this layer over here, and then simply give F5 FCK PU, design PU and design moment, and you can click analysis, and you can draw a PM interaction curve for I section, similarly for S section, T section, cross section. Okay, so this is how this program is very useful for drawing the PM interaction curve for these different cases. Thank you.